So what I'm first going to do is I'm going to set y equal to kx, where k is a constant. So now I'm going to rewrite the equation with y equaling to kx. So this would give us x to the power of kx equals kx to the power of x. Now what I'm going to do is I'm going to take the square root on both sides. And this is the same thing as taking the power of 1/2 on both sides. So this is the same thing as x to the power of kx to the power of 1/2. This is equal to k to the power, kx to the power of x to the power of 1/2. Now, if we have something like a to the power of x to the power of y, this is the same thing as a to the power of x times y. So we have x to the power of k of x to the power of 1/2. This is the same thing as x to the power of kx times 1/2, which is the same thing as x to the power of k of x over 2. And this is equal to kx to the power of x times 1/2, which is x over 2. Now what I'm going to do is I'm going to multiply both sides to the power of 2 over x. So I'm going to take the power of 2 over x on both sides. And that means that we multiply 2 over x to both exponents. Now for this, these two would cancel out and these x's would cancel out. So on our left-hand side, we would be left with x to the power of k. And now on our right-hand side, our 2's here, these would cancel out, and so would our x's. So we would just have k to the power of x to the power of 1, which is simply just k to the power of x. So now we have x to the power of k equals k times x. And now we're going to divide both sides by x. So by doing that, these two cancel. So on this side, we would just have k equals x to the power of k over x. Now, if we have a over m over a over n, so for dividing exponents, this is the same thing as a to the power of m minus n. So right here we have x to the power of k over x to the power of 1. This is actually a 1 equals k. So this is the same thing as x to the power of k minus 1. And this is still equal to k. Now I'm gonna take the power of 1 over k minus 1 on both sides. So by doing that, this would cancel out. And over here, we'd have 1 over k minus 1. So now this would be x equals k to the power of 1 over k minus 1. So now we have our value of x. X is equal to k to the power of 1 over k minus 1. So now we need to find our value of y. Well, we know that y equals kx, right? So this means that if y equals kx, this would mean that y would equal k times x, and we already know our value of x, which is k to the power of 1 over k minus 1. Now, if we want to multiply these two numbers, we would have to add their exponents. So k over here, this is to the power of 1. So 1 plus 1 over k minus 1. And this is actually equal to k to the power of k over k minus 1. I just saved a little time because it's actually really simple to do, just 1 plus 1 over k minus 1. So now we know that y equals k to the power of k over k minus 1. So now, let's say that k is equal to 3. Because it's a constant, so we could set it to whatever we want. Then x here, x would equal, we're replacing k with 3, so 3 to the power of 1 over 3 minus 1, which is 2, and 3 to the power of 1/2 is the same thing as the square root of 3. So we know that x is the square root of 3. So now if we substitute 3 in for the equation for y, we get y equals 3 to the power of 3 over 3 minus 1 is 2. Now, this is the same thing as 3 to the power of 3 times 1/2. And this is the same thing as the square root of 3 to the power of 3. So now, as you can see, we have our values for x and y. And now all we need to do is check if they're correct by plugging them into our equation here. So we have x to the power of y equals y to the power of x. So x, as we already know, is the square root of 3. So x to the power of y, well, y is the square root of 3 to the power of 3. So the square root of 3 to the power of 3. And this is equal to y is the square root of 3 to the power of 3. and x is the square root of 3. So now, the square root of 3 to the power of the square root of 3 to the power of 3 equals the square root of 3 to the power of 3 times the square root of 3. Now, the square root of 3 to the power of 3, well, this is the same thing as square root of 3 to the power of 3 to the power of 1/2 times 3. And this is equal to the square root of 3 to the power of 3 times 3 to the power of 1/2. Now, on the right-hand side, we're going to end up with the square root of 3 to the power of 3 and 1, because this is 1. When we're multiplying exponents, we add our exponents, right? So 1 plus 1/2 is 3/2. Now, on our left-hand side, we have the square root of 3 to the power of... Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x to the power of 5 is equal to 100. Now, what I'm first going to do is I'm going to take the power of 5 on both sides. So now we have x to the power of x to the power of 5 to the power of 5, and this is equal to 100 to the power of 5. Now, I'm going to change the 100 to 10 squared. So now we have x to the power of x to the power of 5 to the power of 5, and this is equal to 10 squared to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 2 to the power of 5, this is going to equal 10 to the power of 2 times 5. And 2 times 5 is simply 10, so this would equal 10 to the power of 10. And also, if we have something in the form a to the power of m to the power of n, because this is simply equal to a to the power of m times n, we could reverse these two, meaning this would also equal a to the power of n to the power of m. So in this case, I'm going to switch the places of x to the power of 5 and 5. So now we would have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 10. And if we have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x to the power of 5 is equal to 10, meaning x is equal to the 5th root of 10. So this is our answer.